Hi Chem students, we got a quick video here for you on removing an ion from solution. And the technique we're going to use for that is going to be precipitation. And I just wanted to start with some aspects of the modeling. So we're going to try to take carbonate ions out of solution here. And I just wanted to remind you, in the solution there's going to be a lot of water all over the place, which we see here. And a lot of those water molecules that are near the carbonates are going to be hydrating the carbonate, meaning that they will be attracted by their positive end to the negative carbonate ions. It's hard to model with the water because it's such a mess. So I'm just going to remove all of the water just to give us some room in our model here. And another aspect of the modeling we should remember is you can't just have carbonate in solution. You can't have a solution with a charge. It's got to have both cations and anions. So this might have been sodium carbonate. So I'm going to add 2 sodiums kind of randomly for each carbonate. So now without the water, this is a better picture of what a solution might look like. We're going to see that the sodiums don't participate in the reaction, so they'll be the spectators. And the first example we're going to use is going to be the one we did during precipitation when we modeled double replacement reactions. And since our goal is to remove carbonate, we have to consult our solubility rules, and we have to find a solution, or at least a cation that will bond with carbonate and make an insoluble solid. And what we picked before was calcium. Once again, you can't just put calcium into solution. That has to come in its own solution with an anion. So generally you would pick something that doesn't react and create multiple precipitates. So nitrate is a good option. So for each of these calciums that came in, there should be 2 nitrates. And again, even though in the formula we write it as CaNO3,2, it's aqueous, so all the ions are floating around separately in solution. So this is the exact same situation that we had for our double replacement reaction. And you check the solubility rules, and there's some new combinations of atoms now. Now sodiums and nitrates could go out together, but they don't bond together strong enough to make the precipitate. But calcium and carbonate do. So they will start to come together and form a lattice, and that will then fall to the bottom of the container with the sodiums and nitrates being the spectators looking on. And this is our solid precipitate that can just be removed by filtering the whole solution, and that solid will stick on the filter paper as the residue. So there's one example there on how to take out carbonate. Let's look at some others as well very quickly, see what works and what doesn't work. So let me take out my calcium nitrate. Another option would be to use, lots of other ions will precipitate with carbonate, like silver. So if I wanted to put silver ions in solution, again, I have to find something that they're going to dissolve with, so I'll make it silver nitrate. So again, for each silver, there's going to be a nitrate here. And now we would start to form a precipitate of silver carbonate. And you need 2 silvers for each carbonate. So you'd start to form a lattice, something like this. And I'm out of silvers now, but that would fall to the bottom as your precipitate. And again, sodium and nitrate would just be your spectators. So that would also work, and lots of other ions that would precipitate with carbonate. There is some stuff that won't work, however. So let's remove our silver nitrate. What if we went back to our sodium carbonate solution and threw in potassium chloride? So I'll throw in a bunch of formula units and 1 potassium for each chloride. And again, they're floating around separately. They're aqueous solutions. And now we've got new combinations that are possible. We could have potassium with carbonate, but that doesn't form a precipitate. Remember, all group 1 ions are soluble. And sodium can now interact with chloride, but again, we know that's a soluble compound. So this would be no precipitate and no reaction. And you see now we haven't separated the carbonate at all. We still have these ions floating around in solution. There's no way we can take a nano tweezers and just pick out the carbonate. So without that precipitation trick, there's really no way to remove the carbonate from solution. So that's it. This is going to take you through question number 3 on the solubility rules worksheet, and it's a good prep for question 4, which will be coming up in a day or so.